Welcome to AI Breakdown, the podcast where we break down recent papers in AI. I'm Megan, and with me is my co-host Ray. Today, we'll be discussing the paper titled GAPartNet, Cross-Category Domain-Generalizable Object Perception, presented at CVPR 2023.
Yes, Megan. This paper proposes a part-based approach to cross-category domain-generalizable object perception and manipulation, which is crucial for building intelligent robots. The authors propose generalizable and actionable parts, GAParts, and construct a large-scale part-centric interactive dataset called GAPartNet to investigate three cross-category tasks: part segmentation, part pose estimation, and part-based object manipulation.
Part-based manipulation is an interesting approach, but what exactly are GAParts, Ray?
Good question, Megan. According to the authors, Georgia, parts are part classes that are generalizable in both recognition and manipulation, and they propose identifying them based on their shape and aligned actionability. They define 9 GAPart classes and provide rich part-level annotations such as semantics and poses for 8,489 part instances on 1,166 objects in the GAPartNet dataset.
Okay, so part segmentation, part pose estimation, and part-based object manipulation, all at the part level. Sounds interesting, but I'm not sure I understand the term domain-generalizable. What does it mean exactly?
Domain generalization means that the algorithm can work on unseen object categories without seeing them during training. In other words, it can recognize and manipulate parts of objects from novel categories in both known and unknown domains. This is a challenging problem in AI, and the authors proposed a robust 3D segmentation method that integrates adversarial learning techniques to improve domain-invariant feature learning.
That does sound challenging. Can you give me an example of how this method works in practice?
Sure, Megan. The authors used point clouds to train their algorithm. Parts in the same GAPart class share similar shapes and have aligned actionability, which ensures few variations in the number of points across different GAParts. They also proposed techniques such as part-oriented feature query, multi-resolution technique, and focal loss to handle context variance, diverse part sizes, and distribution imbalance.
That's a lot of terminology. Can you explain it more simply?
Essentially, their algorithm focuses on the parts that matter the most and are foreground, ignoring the background. It varies the resolution of each image to better identify parts of objects, and it tweaks the loss function to account for scarce parts in certain categories. These techniques help to improve the reliability of the model, not only for seen categories, but also for new ones.
Great. So what were the results of this study?
Their segmentation method outperformed all existing methods by a large margin, both for seen and unseen categories. They achieved 76.5% AP50 on seen categories and 37.2% AP50 on unseen categories. Moreover, based on the part segmentation and pose estimation results, they were able to design part-based manipulation heuristics that could generalize well to unseen object categories in both the simulator and the real world.
That's impressive. Do they have any plans to make their dataset and code available to others?
Yes, Megan. The authors have made their dataset, code, and demos available on their project page.
That's great news for researchers who'd like to try out their methods themselves. Thank you, Ray.
Thank you, Megan.